Imagine opening your eyes to a night sky that looks nothing like the one you know. Not just slightly different, not a few extra stars or a brighter Milky Way. No, imagine opening your eyes to a sky so empty it feels like the universe forgot to load a few textures. A sky where the familiar constellations, the comforting clouds of starlight, and the glowing band of our galaxy have vanished completely. It is 1 trillion years in the future, and the cosmos has stretched itself so far that most of the universe has slipped over the cosmic horizon, too distant for light to ever reach this lonely patch of existence again. If today's universe is a bustling cosmic city, then 1 trillion years from now it has become a sleepy countryside where even the neighbors moved away and forgot to leave a forwarding address. Good evening, curious minds. I truly hope you will enjoy today's video. Before we begin, leave a comment and tell me where and when you're tuning in. And if you find yourself learning something new as you drift toward sleep, consider subscribing, but only if you enjoy these calm journeys through the universe. Now let's begin. That is where we begin this story, at the edge of time, staring into a cosmic darkness so big that the word big feels like an insult. It is like calling the ocean a decent puddle. But before we warp into the future, let's sit with a simple, slightly uncomfortable question. How big will the universe be in 1 trillion years? Not just big in the everyday sense, like, this sandwich is too big to finish. We are talking about a scale so enormous that the human brain, which evolved to remember where we left berries and whether that rustling bush contained a tiger, was absolutely not designed to handle it. Yet here we are, poking that mental boundary with a stick, asking the universe to reveal its far-off secrets. To understand what the universe will become, we have to picture the universe as something that is still growing. Right now, as you listen, space itself is stretching. Galaxies are drifting apart, not because they are moving through space like cars and traffic, but because the very fabric of space is pulling them away from each other. It is like drawing dots on a balloon and inflating it. The dots do not move on their own, but they end up farther apart anyway. The only difference is the universe does not need someone's lungs. It is perfectly capable of expanding on its own, thank you very much, and it will keep doing that for an unimaginably long time. Now imagine letting that cosmic balloon expand, not for the next decade, not for the next century, but for the next 1 trillion years. 1 trillion years is such a large span of time that if you tried to count to it out loud, you would not just run out of breath, you would run out of species. Civilizations could rise and crumble, stars could be born and burn out, and you would still be somewhere around the part where you are arguing with yourself whether you said 900 billion, 830 million, or 840 million. The universe, however, has no trouble handling such numbers. Time is its specialty. In this far-off epoch, the universe will not simply be larger, it will be different in character. Today, when we look out into the cosmos, we see ancient light from distant galaxies carrying messages from billions of years ago. But in 1 trillion years, those same galaxies will be so far away that their light will never reach the observers of that time. The universe becomes a place where seeing to the cosmic horizon is like trying to hear a whisper from another continent. Even the loudest shout of starlight cannot cross the ever-growing distances. This gives the future universe an almost poetic loneliness. Imagine standing on a tiny island in an endless dark ocean where the horizon stretches so far that it might as well be infinity. The only flickers of light nearby come from a few surviving stars in a single aging galaxy. Everything else has faded into darkness, not because it stopped shining, but because expansion pushed it out of reach. It is not that the universe is quiet. It is that it has grown too large for its own voices to carry. And yet, there is something deeply beautiful about this cosmic future. It reminds us that we live in a rare and luminous moment, surrounded by a universe still bright, still communicative, still revealing its history through light that has traveled billions of years to find us. We live at a time when the universe is readable, like a cosmic library whose shelves are still within reach. 1 trillion years from now, most of those shelves will be locked away behind the horizon, inaccessible forever. So as we begin this journey through the far future, let us hold on to that image, a universe growing so large that the night sky transforms into a near empty void, a cosmic quiet that feels both eerie and awe-inspiring. The question is not simply how big the universe will be in 1 trillion years. It is how that unimaginable vastness shapes everything within it. And if you feel your brain stretching a little to grasp it, congratulations. You have just taken your first step into the future universe where everything is bigger, stranger, and lonelier than anything we have ever known. Right now, in this exact moment, the universe is stretching in every direction, the way a lazy cat stretches in the sun, slow, calm, and utterly indifferent to whether anyone understands what is happening. And while this stretching is completely invisible to you and me, it is shaping the cosmic landscape on the grandest scale imaginable. Galaxies today are not sitting still in space like ornaments glued to a cosmic shelf. They are drifting apart from each other as if the universe itself is gently pushing them away, whispering, "Personal space, please." Like an introverted dance partner at the school prom who just wants a little breathing room. To appreciate how this expansion works, imagine placing several raisins inside a ball of dough. As the dough rises, the raisins move farther apart. Yet none of them have budged on their own. They are not sprinting through the dough like marathon runners. The dough itself is doing the work, quietly stretching and carrying everything with it. Now replace the raisins with galaxies, the dough with the fabric of space, and the yeast with whatever mysterious force keeps the universe expanding. Congratulations! You now have a mental model of the cosmos, albeit one that makes you slightly hungry. The fascinating thing is that galaxies are not fleeing through space like rocket ships. If they were, it would be easy enough to explain. Instead, the space between galaxies is expanding. This is the part that makes our brains protest a little, because we tend to think of space as a blank nothingness, not something that can stretch. But space is not just empty air. It is a dynamic fabric that can bend, ripple, stretch, twist, and do all sorts of weird yoga moves that would make any human chiropractor lose their mind. On the scale of everyday life, this expansion is completely undetectable. At no point will you watch your coffee cup slowly drift away across the table because the universe is stretching. Your house will not suddenly expand by 3 inches and demand a higher property tax. Expansion only matters when you zoom out to the scale of millions, billions, and trillions of stars. It is the ultimate example of big picture thinking. If galaxies were people, this expansion would be the slow shuffle backward when someone at a party starts oversharing about their toenail collection, except galaxies are doing it in every direction, all at once. What makes this even more bizarre is that there is no central point where the expansion started, and no outer edge where the universe is stretching into. Every part of space is expanding simultaneously. It is like baking a loaf of bread that has no crust, only interior, and somehow the interior is getting bigger everywhere. When light from distant galaxies travels toward us, it gets caught in this stretching fabric. The wavelength of that light is pulled outward like taffy, making the color shift toward the red end of the spectrum. Astronomers call this redshift, but you can think of it as the universe sending us extremely delayed messages encoded in cosmic Morse code. The farther a galaxy is, the more stretched its message becomes. In fact, some galaxies are receding so quickly due to expansion that their light is barely making headway toward us at all. If light had a face, it would probably have the expression of someone running up a downward moving escalator. Close galaxies are still gravitationally cozy. In our own neighborhood, the Milky Way and the Andromeda galaxy are on a collision course, which is less of a dramatic smash and more like 2 very large star cities slowly merging into one cosmic metropolis. But beyond our local bubble, the story is different. Galaxies farther out are drifting away at speeds that make race cars look like they are taking a leisurely Sunday drive. One of the strange consequences of this expansion is that the universe we see today is a snapshot of how things looked long ago. When we peer deep into space, we are actually looking backward in time, because light needs time to travel. The expansion has stretched that journey, turning the universe into a cosmic time machine where every direction is a window into the past. Astronomers do not just observe galaxies, they listen to the stories those galaxies tell about their younger, more energetic days. And because space keeps expanding, that cosmic archive gets harder and harder to read as galaxies move farther away. Today, cosmic expansion is not particularly dramatic. You will not feel a shiver in the ground or hear some celestial creaking like the universe needs WD-40. It is gentle, steady, and perfectly content to shape the cosmos without fanfare. Yet despite its subtlety, it is the key reason why galaxies behave the way they do. They drift apart not out of choice, but out of necessity, like wallflowers at the dance, trying to find their own quiet corners. In the grand choreography of the cosmos, cosmic expansion is the slow music playing in the background, guiding every motion. And whether galaxies want to dance or not, the universe keeps stretching, expanding the cosmic ballroom wider and wider with every passing moment. If cosmic expansion is the gentle stretching of space, then dark energy is the universe quietly turning up the speed dial when no one is looking. It does not roar like a rocket engine or flash dramatically like a supernova. Instead, it operates with the subtlety of a librarian who reorganizes the bookshelves overnight and leaves everyone wondering why the room suddenly feels bigger. Dark energy is the force that makes the universe expand faster and faster, even though that sounds like it should violate at least 3 different common-sense laws and maybe a building code. To begin understanding dark energy, imagine a cosmic tug-of-war that has been happening since the moment the universe began. On one side, gravity has been pulling everything inward. Gravity is the dependable friend in the group, the one who keeps things grounded, literally. On the other side is dark energy, which seems to be whispering, "What if we did the opposite?" And unlike most cosmic debates that take billions of years to settle, this one is surprisingly decisive. Dark energy is winning, and it is not even breaking a sweat. This invisible pressure acts across all of space, pushing galaxies apart with increasing enthusiasm. It does not cluster like matter does. It does not form stars or planets. It does not emit light or absorb anything. If dark energy went to a party, no one would notice it, yet somehow it would quietly rearrange all the furniture before the night ended. It is everywhere, smooth and uniform, like an impossibly even mist spread across the entire cosmos. And even though it is incredibly subtle, its influence grows with the size of the universe itself. The bigger space becomes, the more room dark energy has to do whatever it is doing. And whatever it is doing seems to involve accelerating the expansion, as though it has a long-term plan and is politely ushering the universe toward it. The strangest thing about dark energy is that it often feels less like a substance and more like a property of space itself. Some scientists describe it as the energy of the vacuum, the restless buzz that even the emptiest void cannot seem to shake off. If that sounds odd, imagine thinking you emptied your backpack, but discovering it still weighs something. In the universe's case, empty space seems to carry a kind of built-in energy, and that energy pushes outward. You could call it the universe's worst-kept secret, except the universe does not talk and has no obligation to explain itself. The effect of dark energy is subtle when you zoom in, but dramatic when you zoom out. Within galaxies, gravity still dominates, binding stars and planets together like cosmic glue. But on the scale of galaxy groups and clusters, distances so enormous your brain might politely decline to visualize them, dark energy takes the lead. It makes space itself expand in a way that accelerates over time. It's as if the universe has decided that strolling was too slow and jogging was beneath its dignity. So now it is gradually easing into a cosmic sprint that will last forever. One of the most astonishing realizations about dark energy is how it reshapes the future of the universe without making a sound. There are no glowing signs announcing its presence. You cannot point a telescope at a dark energy nebula or spot it shimmering in some distant corner of the cosmos. Instead, you observe the galaxies drifting apart, and you notice they are not just drifting, they are speeding up. The distances between them do not simply grow, they grow faster as time goes on. It is the cosmic equivalent of a driver quietly increasing speed on the highway, while insisting they are not touching the gas pedal. We also know dark energy is not a temporary phenomenon. It is not something that will fade away after a few cosmic decades. It has been a dominant player for billions of years, and its influence keeps rising. The more space expands, the more dark energy there is to drive even more expansion. It is a feedback loop that turns the cosmos into a self-stretching fabric with no finish line in sight. If ordinary matter tried to protest, it would be about as effective as a rubber band trying to hold back a hurricane. This accelerating expansion has profound implications for the far future. It means the universe is not heading toward a stable, balanced state. It is heading toward a future where galaxies get pulled apart so drastically that distant ones will eventually disappear from view, not because they winked out, but because dark energy swept them beyond the cosmic horizon. But that is their story. Our focus here is the engine behind this relentless divergence, the quiet force pushing outward in every direction, rewriting the script of cosmic evolution, one tiny nudge at a time. Dark energy does not behave like anything else we know. It does not shrink when compressed or expand when heated. It does not play by rules that feel remotely familiar. In fact, it acts almost like the opposite of matter. While matter grows denser when squeezed, dark energy seems content to maintain the same density even as space grows larger. Imagine having a jar of something that magically refills itself as the jar expands. That is dark energy, a cosmic supply that never dilutes, no matter how big the container gets. And so the universe continues its quiet acceleration, guided by a force that is everywhere and nowhere at once. Dark energy is the cosmic puppeteer that refuses to show its strings, a silent conductor directing the grand expansion without ever stepping into the spotlight. It is gentle, patient, and absolutely unstoppable, a force that will continue shaping the universe's destiny long after its stars have faded, long after galaxies have drifted far apart, long after time itself becomes a nearly infinite stretch of quiet cosmic space. Picture a galaxy 1 trillion years from now, floating in a universe that has stretched itself into something so vast and empty that even imagination feels like it is running on low battery trying to keep up. This galaxy, any galaxy really, no longer sits in a crowded neighborhood the way it does today. There are no sprawling clusters glittering across the sky, no chains of galaxies looping like cosmic necklaces, no deep fields where countless galaxies sparkle like diamonds spilled across velvet. Instead, each galaxy has become a lonely island drifting through a sea that grows darker, quieter, and more remote with every passing age. In this far future epoch, our galaxy, whatever shape it has settled into after its mergers and rearrangements, will have become something much more solitary. The rest of the universe will have stretched so far away that the light from nearly all other galaxies will never reach this patch of existence again. The sky has lost its depth. The old cosmic crowd has thinned out and quietly exited the scene, leaving this single surviving home to wander the vast, empty ocean of space. If the universe today is a bustling city full of headlights and neon and crowded streets, then a 1 trillion-year-old universe is an abandoned coast where only one lighthouse still flickers against a cold horizon. Inside a galaxy of that era, the view is eerily peaceful. Stars remain, though not as many as before. The ones that shine now do so against a sky so ink black that even faint stars look bright, like scattered sparks from a dying fire. 1 trillion years gives a galaxy plenty of time to reorganize itself, settle into new patterns, and drift along its old cycles. Spiral arms that once wound gracefully may have faded into looser, gentler shapes as the galaxy relaxes into a slower, quieter existence. Mergers that once sculpted and reshaped the galactic structure are no longer happening. There are no newcomer galaxies on the horizon. The era of crowd collisions is over. The stars that dominate this future galaxy are long-lived, steady, and surprisingly patient. Most of the brilliant, short-lived stars that once illuminated the cosmos have burned out ages ago. The future belongs to small, cool stars that sip their fuel with monk-like discipline and glow with a soft, persistent light. These stars last trillions of years, and they fill the galaxy with an atmosphere best described as cosmic evening, dim, serene, and stretched out far beyond any human sense of time. If galaxies had moods, this one might feel contemplative, as though it has settled into a slow and thoughtful rhythm after an energetic youth. Drifting through this galaxy, you might find vast regions where the space between stars has grown wider. There is no rush, no frantic forming of new star clusters. The once busy nurseries where stars were born have mostly quieted. The raw materials that fueled millions of generations of star birth have thinned out, like a well that has finally run dry after eons of careful use. What remains are ancient stars and their long, steady burn, lighting the galaxy with an almost nostalgic glow. Surrounding this galaxy is a halo of dark matter, still silently shaping its gravity. Dark matter does not age or dim. It simply persists, holding the galaxy together like an invisible scaffold. But beyond that scaffold there is nothing. No nearby galaxies to tug at it. No intergalactic gas clouds drifting through the void. Even the faintest glow from distant places has been swallowed by the accelerated expansion of space. The galaxy is a lone ship, sailing forever into an ocean that offers no landmarks, no shores, no maps. For any beings who might find themselves living in such a galaxy, which is admittedly a cosmic long shot, the view of the universe would be astonishingly different from the one we enjoy today. They would see only their own galaxy and its faint collection of stars. There would be no visible evidence that other galaxies exist. Even the cosmic background glow would have faded into temperatures so cold they might as well be absolute silence. To them, the universe would appear small, centered around their single galaxy, with no hint of the grand cosmic architecture that once filled the skies. They would have no way of knowing that the universe was ever larger, brighter, or more interconnected than this solitary island they call home. And yet, there is a beauty in this solitude. Galaxies in this time are like ancient ships that have outlasted every storm, still drifting, still glowing, still following their timeless orbits with quiet dignity. They are the final beacons in a universe that has grown spacious beyond comprehension. They carry within them the remnants of countless generations of stars, each one a memory of the universe's brighter days. What makes this picture so haunting is not the darkness or the emptiness, but the stillness. For the first time in cosmic history, a galaxy no longer has neighbors. It no longer shares space with anyone else. It is alone, not in a sad way, but in an awe-inspiring way, like a solitary mountain rising in an endless plain, its silence telling a story that stretches across epochs. By the time the universe reaches the trillion-year mark, galaxies have transformed from bustling cosmic cities into quiet, wandering islands. They drift through a darkening sea, self-contained and self-lit, carrying the last sparks of starlight through an ever-expanding void. They are the survivors of a universe that began in blazing light and now settles into a slow, graceful dimming. And in their lonely glow, the cosmos writes its most introspective chapter yet. If the early universe was a booming maternity ward for stars, chaotic, crowded, and full of newborns screaming photons into the void, then the universe a trillion years from now is more like a cosmic retirement home. The halls are quiet, nobody is rushing anywhere, and the residents have been around long enough to have opinions about everything. Star formation, once the high-energy heartbeat of galaxies, has slowed to a near standstill. What remains are long-lived elder stars drifting through gentle orbits, glowing with the dim, steady light of beings who know they are in no hurry to burn out. This is the age when the universe has settled into its cardigan and slippers, poured itself a warm cup of hydrogen-depleted tea, and accepted that the era of stellar youth has passed. To understand why star formation fades, imagine the universe as a factory that once had endless raw materials. In its younger days, massive clouds of hydrogen gas swirled through galaxies, collapsing into dense knots that ignited into brilliant new stars. Think of enormous cosmic cradles constantly filled with shimmering newborns. But over billions upon billions of years, stars have been steadily using up that hydrogen. Every shining star you have ever seen is essentially a fusion engine burning through a limited supply of fuel. And while the universe has a huge amount of matter, there is not a magical cosmic restock button. When hydrogen gets locked into stars, planets, dead stellar remnants, or is blown out into space and heated beyond usefulness, the star-forming reservoir gradually shrinks. Star formation also slows because galaxies no longer collide and stir things up the way they once did. Collisions might sound catastrophic, and they certainly are messy, but they were fantastic star makers. When two galaxies collided, their gas clouds slammed together like traffic in a very poorly managed intersection, compressing the material into dense pockets that sparked the birth of new stars. In the far future, those collisions simply do not happen anymore. Every galaxy has long since drifted into solitary motion, leaving no one to bump into, jostle, or reignite the old star factories. A trillion-year-old galaxy has as much chance of experiencing a major gas-stirring collision as a retired shipwreck does of winning a speedboat race. As the supply of raw hydrogen dwindles, and the opportunities for compression vanish, the universe naturally transitions from a star-making frenzy into a slow glide. The last newborn stars formed in this era are small, faint, and extremely efficient. These are the cosmic equivalent of centenarians who barely sip their fuel, glowing gently without expending much energy. They will endure for trillions of years more, but they mark the end of the universe's stellar youth movement. No new baby booms await on the horizon. Inside this retirement home cosmos, the remaining stars are almost entirely low-mass red and orange dwarfs. These small stars are experts in frugality. If a star could clip coupons, these would be the ones carrying binders full of them. They burn their fuel at a pace so slow it makes snails look impatient. Their light is soft and warm, not the blazing brilliance of young blue stars that once lit up galaxies like cosmic fireworks. Those hot, massive stars lived fast, burned bright, and died early, leaving behind only memories and heavy elements scattered into space. The stars that remain are content to glow quietly, like lanterns in an endless night. Between these ancient stars lie vast regions of emptiness that were once filled with bustling star nurseries. Molecular clouds, great billowing structures of hydrogen gas, are long gone. Some of the gas was turned into stars. Some was blasted away by supernovas. Some was heated until it no longer clumped together. The galaxy feels spacious now, roomy in a way that is beautiful, but undeniably lonely. If the early universe was a crowded airport terminal, this version is an empty library after closing time. Planets orbiting these elder stars would experience skies quite different from today's. Instead of a galaxy brimming with bright star clusters and glowing gas clouds, the view would be dominated by solitary points of light. The sky would feel older, quieter, and more reflective, cosmic dusk stretching into a near-eternal evening. Any civilization that might exist would never know the thrill of a starburst galaxy or the vibrant glow of star-forming regions. They would grow up in a universe where star birth is folklore, a tale about a time when the cosmos was a wild, roaring furnace of creation. The fading of star formation also subtly changes the rhythm of galaxies. Without young stars blazing in blue-white radiance, galaxies grow redder in tone. The light becomes enriched by the long-lived survivors who dominate the population. Even from within, the galaxy feels like it has entered a gentler phase of life. Not dead, not extinguished, just gracefully winding down, as though settling into a cosmic meditation that could last for ages beyond counting. In this retirement home universe, the drama of stellar evolution continues, but at a slower tempo. Stars still flare, flicker, orbit, and eventually fade, but the grand cosmic nursery has quieted. Each remaining star becomes a precious relic, a living fossil telling the story of the universe's bright beginning. And as the cosmos drifts further into its tranquil twilight, these aging stars become the final keepers of light in a universe that has long since stopped adding new voices to its choir. By the time the universe slips into the trillion-year mark, planets and solar systems are no longer the warm, bustling neighborhoods they once were. They have become quiet travelers drifting through an increasingly subdued cosmos, like old ships sailing through an ever-darkening sea. Whatever drama once filled their skies, solar flares, bright star rises, asteroid dances, has mellowed into something much more muted. This is the era when planets settle into long, cold orbits around stars that have grown dim and tired. The galaxy is no longer a symphony of brilliant starlight. It is a gentle whisper of ancient worlds following their predictable paths with patient precision. To understand this far future life of planets, imagine standing on a world orbiting one of those long-lived red or orange dwarf stars. Gone is the bright, warm glow of a youthful sun. Instead, the sky is lit by a softer, ember-like radiance, as though the star itself has tucked into a winter blanket and is doing its best to keep the lights on. These low-mass stars don't shine like torches. They glow more like cosmic nightlights. For planets, this means a cooler, more subdued climate, where energy trickles in rather than floods. Any daylight feels faint, the way a candle feels in a vast room. Yet these dim stars are remarkably loyal companions. While massive stars live fast and burn themselves out with spectacular enthusiasm, the small stars of the far future prefer the slow and steady approach. They can last trillions upon trillions of years, outliving the cosmic eras when most galaxies still had company. Their planets will orbit them for incomprehensible spans of time, circling with the reliability of ancient gears turning in a clock that refuses to stop ticking. But the planets themselves have changed. Their surfaces, once geologically active and perhaps biologically rich, may have cooled to a state of deep calm. Tectonic plates that once shifted like restless dancers may have frozen in place. Volcanic heat that once bubbled from the interior may have dwindled to faint glimmers, like the last embers in a dying campfire. Over vast ages, radiogenic heat inside planets slowly fades, turning once vibrant worlds into quiet spheres of rock and ice. Some planets will drift outward as their stars evolve. When a star loses mass, whether through gentle stellar winds or the final shedding that older stars experience, its gravitational grip loosens. Planets feel this change immediately. Their orbits expand, stretching into wider and colder paths. Worlds that once bathed in warm light may find themselves pushed into outer darkness, not by choice, but simply because their aging star can no longer hold them as tightly as it once did. It is the cosmic equivalent of your grandmother telling you she can't pick you up anymore, not because she doesn't want to, but because gravity is rude and time is undefeated. Other planets may face a different fate if they orbit stars that swell late in life. Even tiny stars go through subtle phases of expansion, and planets too close may be scorched or swallowed. But the majority will simply settle into the new rhythms of a cooling system, continuing their orbits the way old clock hands continue their slow circling long after everyone else has left the room. Moons too follow the cosmic wind down. Tidal forces weaken over time, and once active moons, those with geysers, molten interiors, or shifting ice shells, may eventually freeze into stillness. Oceans that once shimmered beneath icy crusts might solidify. Magnetic fields may fade. In the trillion-year universe, motion becomes gentle, quiet, predictable, the opposite of the chaotic early days when impacts, eruptions, and shifting crusts were the norm. Some planets may remain surprisingly warm deep within, insulated by thick layers of ice or rock. Heat from earlier ages can linger stubbornly, creating pockets of internal energy that may last for astonishingly long periods. But even these eventually bow to time. Nothing in the cosmos gets to keep its warmth forever. Farther out in the system, comets and icy bodies drift in slow, wide arcs. But without gravitational nudges from youthful chaos, most remain undisturbed. The great cometary fireworks are gone. Instead, these distant objects float in serene, dark stillness, illuminated only faintly by a star that now glows more like a cosmic coal than a radiant beacon. If any civilizations were to exist in this era, their sky would be astonishingly minimalistic. Gone are the bright constellations, gone are the star clusters. Their night would be a quiet black canvas with only a handful of faint points of light. Their concept of the universe might be astonishingly small, simply because so little is visible beyond their local system. The grand scale of the cosmos would be hidden behind distance, darkness, and the accelerating expansion that whisked everything else out of sight. Yet there is a certain serenity to this future landscape. A solar system in the trillion-year universe is not dead. It is simply at rest. It has earned its calm. The frantic, fiery days of youth are long past. What remains is a kind of cosmic retirement, predictable orbits, dim but steady light, ancient planets gliding along their paths with the confidence of travelers who have been on the road for ages beyond imagining. The universe, once ablaze with newborn stars and restless worlds, has eased into a gentle stillness, and the planets, those patient, enduring companions, continue their slow, cold journeys, tracing graceful loops around stars that shine like embers in the enormous dark. In the earliest days of the cosmos, galaxies were social creatures. They formed in tight clusters, chatted gravitationally with their neighbors, tugged, twisted, and sometimes outright bumped into each other. It was a cosmic block party, and everyone showed up. But 1 trillion years into the universe's expansion, the party is long over. The music has faded, the guests have gone home, and the universe has turned into a collection of extraordinarily distant islands drifting through a vast, dark ocean. The emptiness between these islands grows so enormous that even words like expansive and limitless feel like tiny cocktail umbrellas trying to shelter an ocean liner. A galaxy in this far future universe is still a grand structure, a swirling mass of stars, remnants, and dark matter. But what surrounds it has changed dramatically. Once upon a time, galaxies lived in massive clusters filled with interconnected filaments of gas, dust, and dark matter. They were linked together like cosmic constellations, forming enormous webs that spanned hundreds of millions of light years. These webs were the universe's scaffolding, the grand architecture holding everything together. But as space stretches further and further, those connections thin out like taffy being pulled too far, until eventually they snap entirely. This snapping is not violent or explosive. It is slow, gentle, and eerily quiet, like the fading of a distant echo. Over unimaginable stretches of time, gravitational bonds weaken. The filaments that once connected galaxies become so thin that they dissolve into near nothingness. The universe's vast cosmic web begins to unravel, leaving each galaxy surrounded by a moat of expanding space that grows deeper and wider with every passing epoch. Inside the galaxies themselves, things remain relatively stable. Gravity keeps their internal structures intact. Stars continue their slow orbits. Dark matter still holds the halo together like an invisible skeleton. But step outside that boundary, and the universe becomes astonishingly empty. Not quiet country road empty. Not late-night grocery store empty. We are talking about an emptiness so thorough it makes a vacuum chamber look crowded. To understand this, picture a map of galaxies scattered through space. Now imagine drawing arrows between every galaxy to represent their gravitational connections. In the early universe, your map would look like a wildly energetic spider web covered in overlapping lines. But as the universe expands, those arrows stretch. Some become faint, others disappear entirely. 1 trillion years from now, the map would look like a sparse archipelago, a few isolated islands with nothing but vast blank paper separating them. This expansion does not stretch galaxies themselves, because gravity keeps them bound. It is the space between the galaxies that grows, and as the expansion accelerates, the rate at which new empty space appears between these cosmic islands becomes astonishing. Imagine dropping 2 boats into a calm lake and then watching the lake quietly expand under them. The boats drift apart even though neither moves. Now replace the lake with the entire universe and the boats with galaxies, and you begin to get the idea. The emptiness between galactic structures becomes so extreme that even light struggles to cross it. Light, which once served as the great cosmic messenger, now finds itself stretched to longer and longer wavelengths, carrying stories that arrive too quietly to be heard. Eventually, the distances grow so vast that even the most determined beam of light cannot manage the journey. It is like trying to shout across a canyon that keeps doubling in width every time you open your mouth. With every passing era, the cosmic horizon shrinks around each galaxy. This horizon is the boundary beyond which events can no longer influence what lies within. As the expansion accelerates, galaxies find themselves confined to smaller and smaller observable regions. The universe does not collapse. It calcifies into isolated pockets, each one containing perhaps a single galaxy or a small group of merged ones. Everything else drifts away, forever unreachable. Within these isolated pockets, the sense of scale becomes deeply misleading. From inside one of these far future galaxies, everything may seem calm and self-contained. But step back, if you could, and you would see each galaxy marooned in a cosmic gulf so deep and silent it borders on philosophical. The distances between galaxies grow to the point where the word distance stops being useful. Language bends under the strain. Numbers become comically inadequate. Even imagination seems to pull a muscle trying to stretch that far. As the cosmic web dissolves, the structure of the universe becomes more like an enormous mosaic of islands set in an ocean of expanding nothingness. Each island is a galaxy, preserved by its internal gravity, carrying its ancient stars through an expanse that is not merely empty, but continually emptying itself even further. The space between galaxies does not just exist, it grows, inflates, and deepens, making the universe feel like a vast theater after the audience has left, with a single spotlight shining on a lonely stage. The remarkable part is that this growing emptiness is not a sign of the universe dying. It is simply the universe evolving into a new personality. Once vibrant and busy, the cosmos grows older, quieter, and more spread out. Galactic structures stretch and drift until their neighbors vanish beyond memory. The universe becomes a masterpiece of solitude, a realm where each galaxy journeys alone, carrying its own history through an ocean of space that grows wider with every breath of time. Long before galaxies drifted into lonely exile and stars settled into their cosmic retirement, the universe carried with it a soft, pervasive glow, a faint, uniform whisper of light left over from its earliest moments. This glow, known today as the cosmic background, is the oldest light in existence, the final echo of a time when the universe was unimaginably hot, dense, and bright. But 1 trillion years into the cosmic future, that glow is not merely faint. It has slipped so far into obscurity that calling it light feels like calling a frozen pond tea that is taking its time. It is still there, still whispering its ancient story, but the whisper has been stretched so thin by time that it almost disappears into silence. To understand this ancient light, imagine a cosmic furnace that once blazed hotter than any star that would ever exist. In the first moments after the universe began, everything was so densely packed that light could not travel freely. Photons bounced around like frantic fireflies trapped in a jar. Then, when the universe expanded and cooled enough, the light finally escaped. That moment, frozen across the cosmos, produced a glow that filled all of space, an afterimage of the universe's fiery childhood. Today, we see this glow as a faint microwave signal bathing the sky, like a warm memory that refuses to fade. But time is not gentle with light. As the universe expands, the background glow gets stretched along with it. Every wave of radiation is pulled longer and longer, its energy draining away like the last ember in a fading fire. Billions of years from now, let alone 1 trillion, that gentle microwave glow continues to lose energy. It cools, thins, and stretches until it becomes something so subtle that only extraordinarily advanced instruments, or perhaps equally advanced patients, could detect it at all. By the trillion-year mark, this background glow has cooled into a murmur so faint that even calling it a murmur is ambitious. Its temperature has dropped to near absolute stillness, hovering just above zero in a way that makes today's frigid cosmic background seem positively toasty. If the universe had a thermostat, the cosmic background would be clinging to the very bottom edge of the dial, trying its best not to fall off entirely. Picture the glow as an old light bulb in a forgotten attic, once bright enough to fill the whole house with light, but now flickering so gently that you might mistake it for a smudge on your glasses. That is the cosmic background at 1 trillion years. It has not vanished. It has simply grown so faint, so stretched, so chilled, that it becomes practically indistinguishable from the silence of empty space. The cooling of the background glow is not just a temperature story. It is a story of how cosmic history becomes increasingly difficult to read. Right now, the background provides astronomers with a map of the universe's earliest conditions, a baby picture preserved in light. But as the background cools, the details blur. The ancient patterns get stretched out of shape, smoothed into featureless faintness. If future cosmic archaeologists attempted to reconstruct the early universe using this far future background radiation, they would be trying to make sense of a fresco that has faded into a barely visible wash of color. One of the strangest consequences of this cooling is its effect on the nature of darkness itself. As the background glow dims, the universe becomes more truly dark than it has ever been. Today, darkness is simply the absence of bright stars or artificial lights. But even in the deepest void, the cosmic background adds a faint warmth, a quiet illumination threading through the emptiness. 1 trillion years from now, that underlying glow has faded so deeply that darkness becomes purer. It is not just the absence of light, it is the presence of a cosmic stillness so thorough it feels almost physical. Future galaxy dwellers, if any exist, might never know this ancient glow existed at all. Their instruments would encounter a universe that appears cold from the very beginning, as though the cosmos was born not from fire, but from quiet. They would wander through a night without discovering that the night once blushed with a faint and universal glow. The entire cosmic story would be missing its first chapter. And yet, there is something poetic about this dimming. The cosmic background is the universe's oldest lullaby, and over trillions of years that lullaby stretches into a near-silent hum. It is the cosmos exhaling its last warm breath from the age of creation. It is the final ember of the Big Bang's furnace. Cooling slowly but steadily, refusing to go out completely even as space stretches past comprehension. This near-nothingness is not a death, it is a settling, a gentle cooling of the universe's oldest light, like coals fading in a fire that once roared with brilliant intensity. The cosmic background, now stretched across trillions of light years, continues to exist not as illumination, but as a faint, almost philosophical reminder that the universe remembers its own beginning, even if that memory has dimmed into near silence. In this far future, The cosmos carries its ancient glow like a subtle watermark embedded in the fabric of space. Faint, quiet, nearly erased, but still present, still whispering the same message it has for eons. I was warm once. In the early ages of the universe, chemistry was a lively affair. Hydrogen and helium, the cosmic equivalents of flour and water, mixed and collapsed into stars, and those stars cooked up everything else. Every carbon atom in your body, every oxygen atom you breathe, every iron atom in your blood was baked in the heart of a star that lived and died long before Earth existed. The universe was a kind of grand recycling center, taking the simplest ingredients and upgrading them into richer, more diverse materials. Stars were the factories, supernovas were the delivery trucks, and galaxies were the marketplaces where all these elements mixed and mingled. But 1 trillion years into the universe's future, that entire system has wound down. The cosmic recycling program has been discontinued, the factories are closed, and the delivery trucks have long since retired. Heavy elements, once scattered generously across star-forming regions and spread by stellar explosions, have become precious relics. They are the rare gemstones of a universe that no longer produces new ones. If the cosmos had an economy, heavy elements would now be luxury goods, hoarded like ancient antiques cherished for their history as much as their utility. To understand how this chemical scarcity emerges, imagine the universe's earliest stars as enormous, short-lived blacksmiths. They fused hydrogen into helium, then helium into carbon, oxygen, silicon, and finally iron. When those stars exploded, they hurled their creations across space like enthusiastic chefs tossing seasoning across a kitchen. New stars formed from this enriched gas, enabling the next generation to begin its own chemical contributions. The cycle repeated itself like a cosmic assembly line: star birth, fusion, death, enrichment, each generation adding more and more heavy elements to the mix. But the assembly line depends entirely on two things: the availability of fresh gas to form new stars, and the existence of massive stars that can explode and scatter their creations. By the time the universe reaches the trillion-year threshold, both of those components have vanished. The gas has been used up or locked away in ancient stars and planets, and the massive stars, the ones that once ended their lives with explosive flare, disappeared eons ago. The universe has run out of its master blacksmiths. With no new massive stars forming, the main producers of heavy elements are gone. Smaller stars, the ones that dominate the far future, are not capable of forging the heavier elements that once enriched the interstellar medium. They are slow, steady burners, more like cosmic tea candles than roaring furnaces. They hold on to their material, rarely shedding it. The universe's ability to recycle and enrich itself fades until it effectively stops. This means that heavy elements gradually become isolated, trapped in old stellar remnants, scattered across ancient planets, or drifting in bits of cooled debris left over from earlier eras. They are no longer part of a dynamic, evolving cycle. Instead, they settle into a kind of chemical stillness. The cosmos becomes a place where iron, gold, calcium, and all the other elements that once flowed freely become locked away in whatever structures happen to contain them. Galaxies, once bustling with chemical turnover, become chemically static. They no longer produce new materials from within. They simply preserve what already exists. Over immense stretches of time, even the mechanisms that once redistributed elements, like supernovas and stellar winds, fade into memories. With no new violent stellar events to crack open old stars or spread fresh elements, matter stops moving around. The universe's chemical landscape becomes like a library where no new books arrive, and the existing ones grow brittle on the shelves. This shift has profound consequences for the kinds of objects that populate the far future cosmos. Planets formed in this era, if any form at all, would be composed mostly of hydrogen and helium, with only the tiniest flecks of heavy materials. The variety of rocky worlds, so common in the earlier universe, would become increasingly rare. Heavy elements, once sprinkled generously through galaxies, become concentrated in relics, ancient crusts of planets long cooled, dense cores of old stars, and fragments of long extinct stellar explosions. They are not gone. They are simply marooned, stuck in places where nothing stirs them anymore. Over even longer timescales, the very structure of atoms comes under slow but relentless pressure from the universe's cooling environment. But even before those extreme eras arrive, the chemical landscape has already evolved into something fundamentally different. The universe no longer feels like a flourishing ecosystem of element creation. It has become a museum preserving artifacts from a wildly creative youth, but no longer producing or redistributing new ones. If someone living in that distant age, assuming anyone exists, were to analyze the matter around them, they would find a cosmos dominated overwhelmingly by the lightest elements. Hydrogen and helium would still rule the charts. Heavy elements would be so scarce that finding them would be like stumbling upon ancient treasure buried under layers of cosmic stillness. A single iron-rich meteorite might be as valuable as a mountain of gold once was, simply because the universe no longer makes things like that. There is a quiet melancholy in this chemical evolution, but also a strange beauty. The universe progresses from a fiery forge to a place of deep calm. It preserves the products of its early creativity with surprising care. Heavy elements become fossils, evidence that the cosmos once roared with energy, that stars once lived fierce and brilliant lives, that creation was once a wild and ongoing process. The chemical future of the universe is not a story of loss. It is a story of memory. 1 trillion years from now, the cosmos carries its history not in light or in structure, but in the rare and precious atoms that remain as evidence of its vibrant beginning. In the universe's earliest eras, black holes were just one feature among many, a few cosmic potholes scattered between galaxies, interesting but not exactly running the show. By the trillion-year mark, however, the cosmic cast has thinned so dramatically that black holes step into the spotlight almost by default. Stars have dimmed, galaxies have quieted, and the great chemical and structural churn of the cosmos has subsided. What remains are these extraordinary wells of gravity, sitting in the darkness like ancient monuments carved from space-time itself. They are the universe's last heavyweights, its long-lasting echoes of violent beginnings. There is something poetic about the way black holes endure. While stars burn through their fuel and planets cool into silence, black holes remain almost unchanged. They do not shine, but they influence everything near them with unwavering authority. Each black hole is a gravitational anchor that once sculpted the motion of stars, guided the structure of galaxies, and occasionally devoured the reckless material that wandered too close. In the far future, their role as gravitational giants persists, even though the regions around them have grown remarkably empty. Supermassive black holes, the titanic versions lurking in the centers of galaxies, are especially enduring. These monsters, millions or billions of times heavier than stars, once fed on swirling disks of gas and dust. They were the dynamos powering brilliant jets that shot across space like cosmic searchlights. But in the quiet, sparse environment of the trillion-year universe, supermassive black holes find themselves without much to do. There are no bright accretion disks, no chaotic streams of infalling matter, no fireworks of radiation. They sit in the center of their lonely galaxies, dark and patient, still immense, but no longer hungry. You could call them the grand elders of the cosmos, mighty, mysterious, and surprisingly serene. Smaller black holes, the ones formed when massive stars collapsed, drift quietly through their galaxies as well. Many of the stars that once orbited around them have either dimmed into embers or moved into wide, slow paths shaped by the galaxy's aging structure. Black holes become solitary travelers in a universe that has very little left to offer them. They do not complain. They simply wait, radiating nothing, revealing nothing, just silently warping the geometry of space around them. But even black holes, as eternal as they seem, have a weakness: time itself. There's a subtle process, predicted by quantum physics, that causes black holes to lose mass at an agonizingly slow pace. This process, Hawking radiation, is like the softest whisper of energy escaping from the edges of a black hole. It is not a roaring fire or even a steady leak. It is more like an occasional spark flickering off a massive cauldron that refuses to cool. The key to this fading is the event horizon, that invisible boundary surrounding the black hole where nothing inside can escape. Quantum physics, however, allows tiny pairs of particles to pop into existence near this boundary. If one particle falls in while the other escapes, the black hole loses a tiny bit of mass. This is not the kind of mass loss you would notice. If you waited 1 trillion years to see a difference, the black hole would politely inform you that no, it has barely changed its waistline. Yet time, especially cosmic time, is stubborn. Over unthinkably long stretches, so long that even calling them long feels like a linguistic understatement. This slow radiation adds up. Small black holes, the ones a few times heavier than the sun, eventually evaporate entirely. They end their lives in a final, brief flash of energy, as though giving the universe a last wink before disappearing. But this does not happen at the trillion-year mark, not even close. You would need to wait for numbers so huge they make trillion sound like a toddler's counting exercise. Supermassive black holes take even longer to evaporate. The giants at the centers of galaxies will stick around for quadrillions, quintillions, and even further stretches of time than words conveniently cover. When they finally evaporate, they do not do so with a dramatic explosion. Instead, they slowly shrink, millimeter by millimeter, except black holes do not have millimeters, but you get the idea, until they reach a final burst of radiation that marks their exit. It is not a dramatic farewell. It is a quiet dissolution, a gentle fading of something that once ruled gravitationally over billions of stars. As everything else in the universe grows colder and emptier, black holes become the defining structures of the late cosmos. Not because they grow more active, but because everything around them becomes so smooth and uneventful. They are the last sculptors of motion in a universe that has very little left to sculpt. They influence the paths of stray objects, bend the trajectories of ancient remnants, and shape the lonely galaxies that still drift through widening darkness. In this cosmic twilight, black holes serve as the universe's memory. They contain the remnants of countless stars, the ashes of old galaxies, and the accumulated history of matter compressed into impossibly dense forms. And though they eventually fade, they take their time, far more time than stars, planets, or galaxies could ever hope to exist. 1 trillion years from now, the universe belongs to them, not as rulers, not as creators, but as the final guardians of what gravity once made. They stand silent in a cosmos that has grown quiet, patient through an age that has outlasted fire, light, and motion. Their slow evaporation is the universe's ultimate long goodbye, drawn out over incomprehensible epochs, whispered one faint quantum spark at a time. If life manages to hang on in a universe that has drifted into its trillion-year winter, then it deserves a cosmic award for perseverance. Life, after all, began in a young, energetic cosmos bursting with heat, light, and endless chemical opportunities. It grew up surrounded by stars that blazed with enthusiasm and planets that buzzed with geological and atmospheric drama. But in the far future, the universe becomes the ultimate version of lights out. It cools, dims, and slows until every surviving spark of life is faced with the same quiet question. How do you keep going when the cosmos itself is gently tucking everything into bed? Any beings alive in that distant era, assuming evolution, ingenuity, or sheer stubbornness carried them forward, would find themselves living in worlds nothing like the vibrant early universe. The skies would no longer be crowded with galaxies or star clusters. Instead, the heavens would be nearly empty, lit only by the faint glow of their local, long-lived star. The wider cosmos would feel more like a myth than a landscape, an unseen expanse that once existed but has since pulled so far away that no evidence of its former bustle remains. Their universe would feel small, quiet, and ancient, like an old library whose shelves have not been touched in ages. Yet life might not be bothered by emptiness. Life is adaptable. It is resourceful. It is the cosmic equivalent of someone who can make a satisfying dinner out of a half-empty pantry. The real challenge would be the slow cosmic cooling that steals heat, energy, and available fuel from every corner of existence. As stars dim and galaxies isolate, life would need to squeeze energy from sources that earlier civilizations would have shrugged off as hopelessly inefficient. One possibility is that advanced beings learn to harness every scrap of starlight with almost absurd efficiency, picture entire worlds or even artificial constructs wrapped around their dim stars, collecting every photon the way a parched traveler might catch every drop of rain. Instead of basking in sunshine, they would be sipping faint beams from stars that glow more like smoldering embers. Technology, to survive, would need to be built with patience and frugality. Devices would sip energy instead of gulping it, and civilizations might pace their activities on timescales so slow that earlier societies would think they were frozen. Another path might involve moving closer to their fading stars. As stars gradually lose energy, planets might drift into cooler orbits, forcing civilizations to migrate inward or build habitats in regions once too hot to consider. They would not be sunbathers. They would be cosmic warm seekers, inching closer to the last remaining reliable heat sources. Over eons, these migrations could become a slow, continuous march inward, a long pilgrimage toward dwindling warmth. But life is not limited to starlight. In worlds where internal heat lingers, trapped beneath thick ice or deep within planetary crusts, life could take refuge underground or underwater. Even in the coldest cosmic eras, some planets might preserve pockets of warmth, like hidden embers in an ash-covered fire. Civilizations could learn to exploit geothermal energy, tapping into the internal furnaces of planets that still remember their earlier heat. These worlds would be strangely intimate places, no star-filled skies, no sweeping horizons, just enclosed habitats nestled in warmth that must be managed with extreme care. More speculative civilizations might attempt something bolder. They could build vast structures that harvest the faint energy of space-time itself. Subtle vibrations, tiny quantum fluctuations, or the slow, gentle hum of cosmic processes that still persist even when stars fade. These would not be technologies as we understand them today. They would be feats of engineering, so delicate and patient, they border on artistry. A civilization in this era would not rush. Time is the one thing the far future universe has in near infinite supply. Some beings might even take inspiration from the stars themselves, slowing their biological processes to match the sparse energy environment. They could stretch their lifespans not by decades or centuries, but by astronomical factors, living slowly, thinking slowly, and adapting to energy scarcity by changing the pace at which life itself unfolds. A conversation might take years. A project might take millennia. They would not merely live in the long twilight of the universe. They would become creatures shaped by it. But even with adaptation, ingenuity, and cosmic grit, the challenges would be immense. As the universe continues to cool, every refuge becomes temporary. Stars, even the most patient ones, eventually fade. Planetary heat dwindles. The energy landscape becomes patchy and fragile. Civilizations might need to wander, moving from one heat source to another, like nomads crossing a desert in search of rare oases. Imagine drifting through interstellar space inside enormous artificial habitats, each one carrying the last remnants of a civilization, riding the tides of expansion into a silent and sparsely illuminated future. And yet, despite the bleakness, there is something profoundly moving about the idea of life persisting. Life in this era would be a testament to endurance, to adaptability, to the stubborn refusal to let the universe end quietly. They would be cosmic archivists, carrying the memory of a bright, vibrant universe into an age of deep calm. Their existence would be a final spark slipping through the fingers of time, reminding the cosmos that the game is not over simply because the lights are dimming. In the end, life in the trillion-year universe would not be defined by abundance, but by resilience. It would not occupy a universe full of stars. It would inhabit a universe that has grown old and sparse, and still find ways to thrive. The cosmos may turn the thermostat down, but life, in its relentless creativity, might just wrap itself in ingenuity and keep going, one faint photon at a time. Trying to imagine the size of the universe a trillion years from now is a bit like trying to imagine the sound of a color or the smell of a mathematical equation. Our brains simply were not built for this scale. Today's universe is already enormous, so enormous that light, the fastest thing nature allows, can spend billions of years crossing it and still not make it to the far end. But fast forward a trillion years, and the cosmos has stretched into something so gigantic, so wildly inflated, that even calling it big feels like calling a black hole a bit clingy. It is a universe so vast that the distances we struggle with today would seem cute by comparison, like telling someone that your driveway is long because you have to walk a whole 20 steps. Picture the universe today as a sprawling mansion full of rooms, hallways, staircases, and unexpected closets, where galaxies and clusters of galaxies reside. Now imagine someone taking that mansion, attaching it to a balloon the size of the solar system, and spending 1 trillion years inflating it. The walls don't just move apart, they recede at speeds so incomprehensible that if you tried to chase them, you would feel like you were running toward a horizon that keeps stepping backward just to mess with you. 1 trillion-year-old universe is a cosmos where even nearby doesn't mean what it used to. In our era, we classify nearby galaxies as those a few million light-years away. 1 million light-years is already a distance so large that if you drove a car at highway speed without stopping, you would be driving until the heat death of optimism itself. But in the far future, galaxies will be separated by distances many times larger, so large that even light, racing tirelessly across expanding space, fails to bridge the gap. The cosmic fabric has stretched itself into vast plains of nothingness between isolated galactic islands. Trying to visualize one of those distances is like imagining walking from your house to the moon while wearing socks made of molasses. If you were standing inside one of these far future galaxies, the view would be shockingly misleading. The galaxy would look much the same size as it always did, because gravity keeps it bound. Stars still orbit a common center. Dark matter still holds everything together like a cosmic scaffolding. Inside this little island, everything feels normal, but it is the ocean outside that has changed. Beyond the halo of stars lies a gulf that has grown so staggeringly large that it makes the term outer space feel like an understatement bordering on comedy. To picture this, imagine your galaxy as a glowing lantern drifting on a boat in an ocean so wide that the nearest other boat is not just over the horizon. It is farther away than any horizon light could ever reach. Even if that other boat were shining the brightest possible beacon, its light would get swallowed by the constant stretching of space long before it reached you. The distances are not simply too far to see. They are so distant that the very concept of far needs therapy to recover from the attempt to quantify them. At this epoch, the universe contains an overwhelming amount of space compared to the amount of matter. Galaxies once shared the cosmos with billions of peers visible across the sky, each shining across unimaginable reaches. Now those peers are scattered so sparsely that each one occupies a cosmic territory so large it might as well be its own universe. The cosmos has turned into a collection of isolated kingdoms, each one separated from the next by deserts of space, expanding faster than even light can travel. Trying to understand these sizes with human intuition is impossible. So let's cheat. Imagine you shrink the entire observable universe today, the whole enormous bubble of galaxies and clusters, down to the size of a beach ball. Now imagine the trillion-year universe as a sphere bigger than the orbit of Jupiter. In that grotesquely scaled-up cosmos, a single galaxy is not a noticeable dot on the beach ball. It is more like a single grain of pollen floating in the distant atmosphere of a planet-sized balloon. Another way to think of it. In today's universe, galaxies are like neighbors living in the same enormous city, far apart, but still on the grid. In the future, each galaxy becomes a cottage in the middle of its own personal continent, with every other cottage so far away that their light will never, ever reach you, no matter how many trillions of years you wait. This is not distance. It is cosmic isolation writ large across a landscape too immense to traverse, too empty to navigate, and too stretched to ever shrink back. This inflation of space also transforms the meaning of horizon. Today, your horizon, the farthest distance from which light can reach you, is enormous, containing billions of galaxies. In the far future, your horizon shrinks inward even as the universe grows outward. The cosmos expands faster than information can travel, leaving each galaxy trapped in a personal bubble of observable reality that gets smaller and smaller over time. You see less and less, even as there is more and more universe out there. The trillion-year universe is not merely large, it is absurdly, profoundly, extravagantly vast. It is a realm where scale stops being a measurement and becomes a metaphor for emptiness. The cosmos has stretched itself into a realm so wide that even imagining it feels like trying to fold a map of infinity into your wallet. And within that breathtaking immensity, each galaxy shines on alone, its own tiny speck of light drifting in an ocean that has grown far beyond any imagination, vast enough to make the universe of today feel like a cozy studio apartment by comparison. By the time the universe reaches its trillion-year milestone, its story has stretched across so many eras, transformations, upheavals, and slow fades that you might think the ending is already written. Galaxies have drifted into solitude. Stars have aged into a slow cosmic twilight. Space has expanded into an enormous, echoing gulf where even light grows weary from the journey. But the truth is, even after a trillion years, the universe may still be in the early chapters of its ultimate fate. The question of what comes next hangs in the air like a quiet cosmic cliffhanger. Will the universe continue expanding forever, or is all of this stretching merely a prelude to some new phase we cannot yet imagine? This question depends entirely on the nature of dark energy, that mysterious, invisible force that currently drives the universe's accelerated expansion. Right now, dark energy behaves with an eerie steadiness. It spreads uniformly throughout space, pushing everything apart with what seems like unfaltering confidence. It acts like the universe's silent metronome, tapping out a steady rhythm of expansion. But the tricky part is this: we do not actually know what dark energy is. We only know how it behaves today. And just because something behaves one way now does not guarantee it will behave the same way a trillion years later. The universe, especially when left alone for absurd amounts of time, has a habit of revealing plot twists. There are a few possibilities for what dark energy might do. The first is that it continues exactly as it is now, steady, patient, and persistent. If that is the case, then the universe will keep expanding forever. Space will stretch until every distant galaxy vanishes from every other, until every star fades into embers, and until time becomes a nearly infinite quiet plain scattered with lonely remnants. Expansion would never slow down. The universe would never relax. It would simply keep growing, thinning itself out into a vast, cold realm where isolation becomes the default state of everything. Imagine the universe as a loaf of bread rising endlessly in the oven, growing lighter and airier with each passing moment until the dough becomes so diffuse it barely counts as bread anymore. That is the expand forever scenario. Space stretches, light fades, matter drifts, and dark energy remains the calm, unstoppable force urging the expansion onward. In this version of the future, there is no cosmic reunion, no great collapse, no return to the fiery state in which the universe began. There is only the slow, quiet unfolding of infinity as the universe becomes more and more spacious. But this is only one possibility. Another is that dark energy might change its behavior over time. Perhaps it weakens. Perhaps it strengthens. Perhaps it does something that current physics has not even dared to outline on a chalkboard, because it would sound like the universe deciding to reinvent its own rulebook. If dark energy were to fade in strength over enormous timescales, the cosmic acceleration might eventually slow. Expansion could still continue, but more gently, like a runner who gradually eases into a stroll. Galaxies would remain isolated, and the universe would stay vast, but the relentless acceleration would ebb. In this scenario, the universe becomes a place that keeps growing, but without the frantic pace dark energy once enforced. The more dramatic possibility, though increasingly unlikely according to today's measurements, is that dark energy could reverse. If it ever began to weaken enough or even turn negative, gravity might slowly reclaim its influence across the cosmos. Expansion would eventually halt, like a tide reaching its peak, and then the universe would begin contracting. Over unimaginable stretches of time, all the vast empty gulfs would shrink. Once isolated galaxies would inch closer. The cosmic fabric would slowly tighten. The universe, which spent trillions of years stretching outward, would begin folding itself back in. If that were to happen, the cosmos would head for a spectacular finale known as the Big Crunch. Everything, the stars, the galaxies, all the lonely islands of matter, would collapse inward toward a final, fiery convergence. Temperature would rise, density would skyrocket, space would tighten into a shrinking sphere of unrelenting heat. The universe would end in a furnace not unlike the one in which it began. And who knows what comes after that? Maybe another expansion, maybe another universe, maybe a cycle repeating like cosmic breathing across eternity. There is yet another possibility, stranger than either endless expansion or eventual collapse. Dark energy might not merely accelerate expansion, it might accelerate it so aggressively that the universe is eventually torn apart at every scale. In this extreme scenario, expansion does not just separate galaxies. It begins pulling apart clusters, solar systems, planets, molecules, atoms, and eventually space-time itself. This fate, nicknamed the Big Rip, would not be subtle. It would be the universe's version of over-caffeinating and tearing its own notebook apart, page by page. But the truth is, the trillion-year universe lives in the shadow of uncertainty. Dark energy is like a cosmic actor who has delivered only the first few lines of a very long script. We can measure its current influence, but we cannot tell yet whether its performance will change tone, volume, or direction as the drama unfolds. If it remains steady, the universe glides into eternal expansion. If it changes, the universe might drift toward collapse, transformation, or something entirely unexpected. The most humbling part of all this is that even 1,000,000,000,000 years, an amount of time so large it makes human history look like a sneeze, is not enough to reveal the universe's ultimate fate. The cosmos is still evolving, still writing its own future, still shaping itself in ways that will take far longer than even these incredible epochs to fully play out. Whether it expands forever or shifts into another phase, the trillion-year universe is a reminder that cosmic time is a vast and unpredictable frontier, and the story is far from over. Picture the universe as a grand movie, one so long, so sweeping, so intricate that it makes every epic saga humans have ever created look like a short commercial. In this cosmic film, you and I and everyone alive today occupy a tiny sliver of the very beginning. Not the opening scene, we miss the flashbang chaos of the first moments by billions of years. But we arrived early enough to see the universe still glowing, still crowded with brilliant stars, still brimming with energy and motion and light. In the grand timeline of everything that ever will exist, we are living in what amounts to the cosmic golden hour, warm, bright, and filled with all the visual splendor a universe has to offer. This is the era when galaxies still shimmer across the night sky like far-off cities full of luminous windows, when nebulae glow with star birth, when constellations dot the darkness with patient precision, when the cosmos feels alive and dynamic like a vast stage with countless actors still performing their parts. In the far future, as the universe drifts into expansion and solitude, that stage grows emptier and quieter. But now, in our moment, it is bustling with celestial life. There is something profoundly cinematic about looking up at the sky today. You are seeing ancient light crossing billions of years to reach you, messages from the universe's more energetic youth. Every star you see is a glowing bead sewn into the tapestry of a cosmos that still has enough density and heat to produce spectacular wonders. We live in a chapter when the universe is crowded enough to explore, bright enough to study, and stable enough for planets' chemistry and biological curiosity to thrive. For a creature that evolved on a small blue world orbiting an unremarkable star, this is cosmic luxury. Future eras, awe-inspiring in their own right, will not have this view. 1,000,000,000,000 years from now, the universe will be a place of immense silence, where galaxies have drifted out of sight and the cosmos has faded into deeper and deeper shades of black. The night skies of far future civilizations, if any endure, will be empty canvases lit only by the few remaining stars in their solitary galaxy. They will never see the crowded sky we see now. They will never witness the sprawling architecture of the cosmos. They will never trace the outlines of galaxies scattered across the deep cosmos, because no matter how powerful their instruments become, those galaxies will be beyond reach, pulled over the horizon by endless expansion. In a strange way, that makes our moment precious. We are living at a time when the universe is both old enough to be fascinating and young enough to be legible. The cosmic background glow is still bright enough to be read like a birth certificate. Distant galaxies still send their light our way, offering glimpses of eras long gone. We can reconstruct the story of how everything formed because the evidence is still visible. We live at a time when the universe shares its secrets generously, long before it grows too vast and dim to communicate them. It is tempting to feel small when contemplating cosmic scales. After all, the universe is enormous. It is ancient. It is filled with forces and structures that dwarf everything human. But that smallness transforms into something surprisingly comforting when viewed from a wider angle. You are not insignificant. You are early. You are living in the rare window when the universe is bright, when the galaxies are close enough to see, and when stars still shine with youthful enthusiasm. You are part of a generation that gets to witness the universe as it writes the bulk of its luminous story. Think of the cosmic epics like chapters in a book. The earliest chapters were fiery and frantic. The later ones will be long, slow, and quiet. We happen to be in the middle of the most cinematic act, the sweeping montage where galaxies swirl, stars ignite, and the cosmic landscape sparkles with activity. We live during the brief time when the universe is both comprehensible and breathtakingly active. Billions of years from now, even the most advanced beings may look back at this era with a sense of nostalgic wonder, marveling at how rich and bright it once was. And so, in this final chapter of our story, we loop back from the trillion-year horizon to this present moment. Our time in the universe is fleeting, but it is woven into a chapter that may ultimately be one of the most remarkable the cosmos ever offers. We are stargazers in a universe that still has stars. We are thinkers in a universe that still has mysteries visible in every direction. We are listeners in an era when the cosmos still speaks loudly and clearly. As the universe expands and ages, its story will stretch into epochs beyond imagination. But today, right now, we get to stand under a sky full of distant galaxies, each one a shining reminder that we inhabit a rare, brilliant moment in cosmic history. It is a comfort to know that in a universe destined for quietness, we find ourselves living in its brightest chapter, witnessing its most spectacular scenes before the great hush arrives and the cosmos settles into its long, serene dusk.